This video is the final part of a three-part series focusing on 8th grade standard NC 8EE7, solving multi-step equations in one variable with variables on both sides of the equation. Continuing to build a conceptual understanding of solving equations with variables on both sides, this video will use manipulatives and tiles to model what's occurring as you move variables and constants across the equal sign while maintaining balance. In parts 1 and 2, we modeled how to represent terms with tiles, key concepts of equality and additive inverse, and modeling two-step equations with tiles. This video will model the connection to the algorithmic steps for solving equations, as well as the multiple types of solutions that you will find when solving equations. The first equation we will look at is 9x minus 6 is equal to 5x plus 18. We will look at this equation simultaneously at the concrete representation and the algebraic to help connect the reasons behind the algebraic steps that we develop. On the left side, we have the algebraic thinking, and on the right side, we have the representational for the same process. We will model and solve our equation using the same steps that we did in part 2 of our video. Let's first model the expression using the appropriate tiles. For positive 9x, we will use 9 green x tiles, and for negative 6, we will use our red tiles. For positive 5x, again we'll use our 5 positive green tiles, and for positive 18, we'll use our yellow square unit tiles. We'll look first on either side of the equation to see if there are any like groups or like terms that can be combined. There are no like groups or like terms, so we'll leave our equation just as it is. 9x minus 6 equals 5x plus 18. Now we'll look to try to combine our like terms in order to move towards isolating our variable, or getting the variables all on one side together. Now remember, it doesn't matter which side you move your variables to, nor does it matter which you try to combine first, your variables and your constants. In our last video, we combined our variables first. However, in this example, we'll work to combine our constants first, just to show you that order doesn't matter. Let's focus first on the negative 6. In order to move this negative 6, we have to think about what would create zero pairs, or what is the opposite or additive inverse of negative 6. The opposite of negative 6 is our positive 6. If we add in 6 positives on the left-hand side, we also have to add in 6 positives on the right-hand side. We can see that our desired zero pairs have been created. We can model that step by writing plus 6 on the left-hand side under our constants, and plus 6 on the right-hand side, again under our constants. Notice that we never combine our variables with our constants together, as they are not like terms. Once we have identified our zero pairs in our model and in our algebraic representation, then we can combine our zero pairs and begin to simplify our expression. On the left-hand side, we can bring down our 9x, and our 6 zero pairs will cancel out. And on our right-hand side, we can bring down our 5x, and our 18 plus our 6 that were added, no zero pairs were created to cancel out, so we'll bring down all of those, totaling 24. So our simplified version at this time is 9x equals 5x plus 24. Now we've combined our constants, our next step is to focus on our variables. Let's look at our positive 5x. Now the opposite or the additive inverse of positive 5x is negative 5x. Of course, if we add it in on the right side, we also have to add in our 5 negatives on the left side. Notice when we write that algebraically that adding in a positive looks like a positive, but adding in a negative looks like you are subtracting, as negatives and subtraction have the same value or give you the same operation. Once we've written that, then we go ahead and look for our zero pairs on our right-hand side and our left-hand side. On the right-hand side, we have created 5 complete zero pairs. Of course, those zero pairs will cancel each other out. So once they go away, we can bring down the values that are not being used, our positive 24. On our left-hand side, again, we will look for our 0 pairs, take away the 5x from the 9x, they disappear, and we bring down what's left, 4x. So our simplified version at this time looks like 4x is equal to 24. We can see that we've taken 5x away from the 9x, and we've also taken 5x away from the 5x was there on the right-hand side. Now that we've gotten our variables isolated on one side of the equation together, now we want to think about what is each x equal to. So now we have 4 x's, and we want to divide them into equal groups. Essentially, we are looking at the coefficient that is on our term to help us decide the number of groups, because we only want one x in each group. So we will divide our x's into 4 equal groups. So if we divide our left side by 4 equal groups, we also have to divide our right side into 4 equal groups, giving each x the same number of constants. As we can see, there are 6 constants equal to each x, so the value of x is equal to 6. Let's look at one more example. In this example, I will first point out that even if another variable is used, it can still be represented by the x tile or the x drawing. Essentially, it is any variable that you're looking for in the problem. Also in this example, we'll focus a little more on the algebraic representation, as well as try to highlight different solution types that you may come into contact with when solving equations. First, let's look to model the equation with the appropriate tiles. We have 9x plus 3 equals 5x plus 7 plus 4x. Notice I've substituted x's for my variables, as it will help in the conversation that we will have as we model it with tiles. In our model, we have 9 positive x's and 3 positive square unit tiles. On the right side, we have 5 positive x's, 7 positive square unit tiles, and 4 positive x's. Our first step is always to look to see if there are any like groups of tiles that can be combined on the left-hand side or on the right-hand side. If you notice, you have your 5x's and your 4x's on your right-hand side that can be put together as one larger group. When we put those together, we will simply bring down our simplified version of that problem. On the left-hand side, we will bring down our 9w and our positive 3. On the right-hand side, we will combine the two separate groups to one larger group of 9w and then bring down our 7. Our new simplified version at this point looks like 9x plus 3 is equal to 9x plus 7. Notice anything about this equation? Notice anything about the variable terms? Let's continue to work in to see what's happening. Our next step is to combine our square tiles together to get all of our constants on the same side. Let's focus first on positive 3. We want to look for the additive inverse, or the opposite of positive 3, which is negative 3. If I add in 3 negatives on my left side, I also want to do the same thing on my right side. Writing that algebraically, it will look like adding in a negative or subtracting 3 from both sides. Notice again, we subtracted 3 from the constants, not from the variables. Our next step is to look for our 0 pairs on our left side and on our right side so that we can cancel them out and write what we have left. On our left side, all 3 0 pairs canceled out, and we're just left with 9x. Our 0 pairs will go away. On our right side, we have 3 0 pairs again, and they cancel out, and we're left with our 9x. Our 0 pairs go away, and we bring down our positive 4. Our simplified version at this time looks like 9x on my left side is equal to 9x plus 4 on my right side. Our final step is to get our variables together on the left side and then to find out what each individual variable is equal to. So we will look at the opposite of 9x, which is to add in 9 negative x's. If we do it on the right-hand side, we also need to do the same thing on the left-hand side. That, of course, can be modeled by subtracting 9x from the left and subtracting 9x from the right. Again, notice that we're always subtracting variable terms from variable terms, not combining them with constants, as they are not like terms. If you notice in this problem, we've created 9 zero pairs on the left-hand side, which ends up with a 0 value. We also created 9 zero pairs on the right-hand side, which will cancel out again and give us 0. And we bring down our 4 constants that are left. This solution is a slightly different solution than we normally see with solving equations. What this actually means is 0 x's is equal to 4. So we cannot find the value of x that's equal to 4, nor can we find the value of x at all. In this solution, because this is not a true statement, because 0 is not equal to 4, this gives us a no solution, meaning that there is no number that can be substituted for the variable w to make this equation true. In review, the focus of this video is to make the connection between the concrete and the representational strategies to the algebraic representation of solving multi-step equations with variables on both sides in the 8th grade standard.